Cherish hope. Breathe. Take a moment, take a few, and someday soon you'll once again be able to stare in wonder at this magnificent view. The world's a crazy place right now, but don't worry, we'll still be here. We'll see you again soon.
Today we're looking then at the sine rule. This is now when we work in any triangle, the sine rule. And as we said in the previous lesson, the first thing that you need to understand is that in a triangle, if this is triangle ABC, then this is side A, this is side B, and this is side C. That's the first very important fact that we need to know and what we're going to use here. Now, we can use the sine rule to find angles all the sides. And you will use this one if you have two opposite ones. So the angle and the side, and another angle and a side. Or it might be C as well. So the rule says A over sine A is equal to B over sine B. But it doesn't matter now, it might be C as well. Two sides and two opposite angles. The one that you want to calculate is the one that we're going to put in the left-hand top. So if it is a side, we're going to use this one. But if it is an angle, then we will say sine A over A is equal to sine B over B. So the one that we want to find is in the left-hand top. Now in your textbook, this is now, try now, you'll find it, it starts then there on page 467 where they explain it. And we're looking then now at try now 27, page 468. Page 468. They haven't drawn the triangles for you, so in the first place we're going to draw them so that we can see what we are talking about here. Now it is triangle LMN, and now they say that angle L is 60 degrees, angle M is 34 degrees, so I've got two angles there. LN is 3.8 centimeters, and this is what we need to calculate, MN. So if you look here, you can see I've got a side and an angle, or opposite side and an angle, and the same thing here, the opposite side and the angle. And that's when we're going to use that sine rule. So I'm going to put the one that I want to calculate in the left-hand top. So this is then x over sine 60 degrees, which is equal to 3.8 over sine 34 degrees. So the opposite side and angle, opposite there. Now to calculate it now, this is with algebra that we will do it. I want to find x, so this is going to be 3.8. To get rid of this one here, to have x alone, I will multiply with sine 60. So what I do on the one side, I do on the other side, and then we divide by sine 34 degrees. And that's then just a calculation that we're going to do on our calculators. So 3.8 times sine 60 degrees is equal to divide by sine 34, and I got 5.885. It's also important that we will look at the rounding. So I got here 5.885. Sides are going to be rounded to 3 significant figures. So there is 3 significant figures. Will the 5 influence the 8? Yes, and it becomes then 5.89. 5.89. Right, number B. Try now 27. Again, we're drawing the triangle PQR. Now, if I look there, I see that P is actually 120 degrees, so perhaps we can rather draw it like this. That one is 120 degrees, R, and this is then Q. Angle Q is 20 degrees, and PQ 57 centimeters, that one then 57 centimeters, and I have to find RQ. That is what I want to calculate, RQ. Opposite sides, opposite angles. No, because I actually need this angle. Can you see? I've got that side, but I need that angle there. It must be opposite. But we can easily calculate it in here, and we know then that R is going to be 40 degrees. So now I can use my sine rule. Remember that sine rule says A over sine A is equal to B over sine B. So we want to calculate X or QR, and we put that one in the left hand top. So this is now QR over sine 120 degrees is equal to 57 over sine 40 degrees. And again, to get QR now, I will multiply here, and I will also multiply on the right-hand side, sine 120 degrees, divide by sine 40 degrees. Divide by sine 40 degrees. So on my calculator, 57 times sine 120 is equal to divide by sine 40. And the answer is then, I got 76.795. Again, rounding it then to 3 significant figures. There's 3 significant figures. Will the 9 influence the 7? Yes. And it is rounded then to 76.8. 76.8. Okay. Right. The next one is number C. In triangle ABC, so I draw the picture so that I can see which one is which one. A, now they say A, the small letter A is 8. Angle A is 70 degrees, and angle B is 32 degrees. And we have to find B, which is now this one, the small letter opposite the angle. So that will then be over sine B, sine 32 degrees, is equal to 8 over sine 70 degrees. So I will multiply 8 times sine 32, divide by sine 70, and the answer is, I got 4.51 centimeters. The next one is number D. Again, triangle PQR. We again have an obtuse angle there, Q, which is 105. So PQR. P is 27. And R is 15. R is the small letter there. So that one is 15. And we have to calculate Q. this one here. Opposite sides, opposite angles. Now here we can see we need angle R because this one is opposite that side and we don't have that one. But we can easily get that. So it is 180 minus 105 minus 27, which is equal to 48 degrees. Don't just take any angle. They must be opposite the side. So I want to calculate Q. Q is opposite sine 105 degrees is equal to, and now I'm taking this one, so it is 15 over sine 48 degrees. Here we do multiplication. 15 times sine 105, divide by sine 48, divide by sine 48, and the length of Q is then 19.5 centimeters. So these ones were all about finding the side. Okay. Now we're going to look at the next one where we are finding the angle now. So this is now try now 28, and we are busy on page 469. Page 469. Right, the first one there, I draw the picture. This is triangle PQR. Q is 50 degrees. PR is 4 centimeters. QR is 5 centimeters. And now the question is, find angle P. Find angle P. I use the sine rule when I have opposite sides and opposite angles. This time we're going to put the angle at the left-hand top. So I'm going to start with sine P. I reverse the formula. Sine P is opposite 5. And then here, sine 50 degrees is opposite 4. This time you want to calculate sine P. So sine P is then equal to 5 times sine 50 divide by 4. And now remember you want the angle, so we'll have to press on the calculators now. Second function, sine, brackets, 5 times sine 50 divide by 4, you'll have to use extra brackets there, is equal to, and the answer is 73.2 degrees. This is now angles, so angles is to 1 decimal place, 73.2 degrees there. So it works very easily. Number B. So again, we've got a triangle ABC. And this time, C is 13. This is opposite. So this is C, this is B, this is A. B is 20. So that one is 20. And angle C is 35 degrees. Now we have to find B. So the question is, what will B be? That is the one that I'm going to put in the left-hand top. So sine B, which one is opposite here? 20, is equal to sine 35 over 13. Opposite sides and angles. So you want sine B. So this is going to be 20 times sine 35 divide by 13. And again, this is the angle that you want to calculate. So this is a second function sine, brackets, another bracket, 20 times sine 35, close your bracket, divide by 13, close, and I got 61.9 degrees. Good, very good. So the sine rule, this is in every paper. We're going to get it every time. Now we're looking at try now 29. Now this is now a mixed exercise, and now you have to look what do you need to find every time. First do the sums and then you mark them. So again, we've got a triangle, PQR. PQR, I hope you can also see that you cannot do this unless you have a sketch from what you are working. So Q is 50 degrees, PR is 5 centimeters, QR is 4 centimeters, and I need to find angle P and R. I need to find both angles there. Now, which one will I find first? Remember, opposite sides and opposite angles. So those two are opposite, and these two are opposite. So I will start with P. So sine P over, which one is opposite that one? 4 is equal to sine 50 degrees over 5. So sine P is equal to 4 times sine 50 divide by 5. So you will see every time I write P, I don't stick to sine P because then it's mathematically not correct. So you have to rewrite it as P. And we do this with second function sine brackets, another bracket, 4 times sine 50 close, divide by 5 close is equal to, and I got 37.8 degrees. 37.8 degrees. No, sorry. This is now the wrong one. Number A. Yeah, 37.8 degrees there for P. Now, it's easy now to get R from there. You don't even need to do calculations. We can just say then that 180 minus that one minus 50 degrees, and the answer 180 minus 50 minus 37.8, and my answer is 92.2 degrees. So I can just get the answer there. Question B. In triangle ABC, so there's my triangle ABC, and C is 13. Now let's just label them again. This is C, this is A, this is B. So C is 13, B is 20, and C is 35 degrees. That one is 35 degrees. And we have to find angle B. Now, this is not the right one here. Let's just redo this one. Number B. So there's the triangle ABC. ABC. And let's label them again. This is B, this is A, this is C. Make sure that you understand that. So C is 7, B is 5, and C is 47 degrees. There is C, 47 degrees. So we have to find angle A. They want A. So that means that sine A, which side is opposite? C is 7, B is 5, angle C is 47 degrees, find angle A. Now this one is going to give a problem because I don't have opposite sides and opposite angles. ABC, C is 7, B is 5, and C is 47 degrees. Right, so we cannot directly find A now here because you can see I don't have an opposite side and an opposite angle. So I'm first going to find B because there I have a side there. So sine B over 5 is equal to sine 47 over 7. Now it is possible to find B, and then we will find A. So 5 times sine 47 divide by 7. This is a second function because you want the angle, second function sine, and I get that B is then 31.493. I'm not going to round off now because I will round off in a final answer. And now we can find a 180 degrees minus 47 minus that 31, and my answer is 101.5 degrees. Then I can find that angle then there. Right, question C. Triangle KLM. KLM. K, so again, let's label them first. So this is K, this is L, and this is M, the small letters. So K is 9, this one is 9, M is 4, and K is 130. Divide by 9. You want to find the angle, so it is second function sine, and I got that M is then 19.9 degrees. And then it is calculate the last one because it's 180 minus 130 minus 19, and L is then going to be 30.1 degree. 30.1 degree. So this is the sine rule. And we have then one last exercise there. First do that one. Try now 30. And this is just a practical one that we have there. In the diagram, so it looks like this. In the diagram, A and B are two opposite sides on the bank of a river. And the angle here is 45 degrees. A man swims 180 meters. This is now this distance here from B to N. Assume that the river banks are parallel, and this length here is 237. So what we want to calculate now is A, N, B. So we want to find this angle. Can I use the sine rule? Yes, because you have opposite sides and opposite angles. So sine N over 237 is equal to sine 45 over 180. So to find that angle, it is sine N is then 237 times sine 45 divide by 180. Second function sine, because you want that angle, second function sine, and my angle is 68.6 degrees. 68.6 degrees. Make sure that you press your calculators correctly. If you get wrong answers, it means that you'll have to use extra brackets here to get the correct answer. And then they say the distance AN. So now this is what we want to calculate. So it is then AN over, now we have to put it over the opposite angle, isn't it? So I need B. I don't have B at this stage. So it will then be 180 degrees minus 45 minus that 68.6 degrees, 66.4. So over sine 66.4 is equal to, and now I'm going to take this 2, so it's that length. Remember, they must be opposite each other, over sine 45. And if we press the calculator now, AN, and it's then 180 times sine 66.4 divide by sine 45, and the angle is then, or the distance then is 233 meters. The distance there. Right, now the last one on the sine rule. Christo is making a map of his local area. He knows that the monument So let's have a triangle. There's the monument, his house, and the sports center. So the monument is 460 from his house, and the sports center is 406 from the monument, and angle HSM is 70 degrees. This is my information, and I have to find H. This is what we want to calculate here. Do I have opposite sides and opposite angles? Yes. So I can say that sine H over 406, the opposite one there, is equal to sine 70, and this one is opposite 460. So sine H is equal to 406 times sine 70 divide by 460. Second function sine, and we can calculate H then there, 56.0 degrees. Right, grade 11s, that is then sine, the sine rule.
ShopRite is your home of low prices this Christmas with unforgettable savings on everything you need. Stock up this festive season with great deals, like 2 kilos of jungle oats for $49.99 and omaere just $34.99. Don't miss out on unforgettable savings at the home of low prices this Christmas. Only at ShopRite. Lower prices you can trust, always.
Grade 11s. We continue then now with trigonometry. We are still busy with trigonometry, and today we're looking at the area of a triangle. Now, we know now of a right angle triangle, it is half base height. We can work with that one, half base height. But then we're going to look in the area of any triangle. ABC. Now, before we start with that, you first need to understand the following. We label this opposite the angle with a small letter. So that is side A, this is side B, and this is side C. And the formula that we're going to use now for area in any triangle is half BC sine A. Now, if you look carefully there, you will see it's always two sides and the included angle that we're going to use to calculate these areas. In the textbook, you can look there now on page 463, and we're looking at try now 23. Now, this is very easy because this is just in right angle triangles. If you look there on the exercise, it's just a right angle triangle. We work with half base height. Just remember that your base and your height must be perpendicular. So if we take the first one there, number 1A, it will then be a half of 24 times 8. And my answer there is 96 square centimeters.